So, is this as efficient as you anticipate it being? Any time in our lifetime? Like, is it the trip to Mars is like what, 6 months? Is that what the idea is?
Yeah, it's about 6 months.
Do you ever anticipate it being quicker than that? Is it
Yeah.
possible to make these things faster? Would you have to have solar sails? Like,
No,
would you
solar
have,
sail will be very slow.
would it be?
I'm trying to think of like the way to think about gravity here. There's a lot of analogies, but like you can think like space itself is curved, like it's like a funnel. Like if there's something that has a lot of mass, it's creating like a funnel, and so in the same way, like if you have a coin funnel and the coins the coin thinks it's going in a straight line, pretty much. Uh, you know, well, the physicists out there might have quibble with my analogies, but anyway, I'm trying to convey what gravity is like a funnel. And so if you want to get out of that gravity well, you actually need to go very fast parallel to the Earth's surface. And the faster you go parallel to the Earth's surface, the further out you spin. So, or you can think of like a marble in a funnel. Like if you want that get that marble to go far out, you just spin it sideways, and it'll spiral out. And conversely, if you just due to the friction of the air friction and the rolling friction, it will slow down a little bit if you don't give it any push, and will slowly spiral in. And then as it gets closer, it spins faster and faster. And this is how gravity basically works. All the things in the solar system are spinning around this gigantic funnel in space-time called the sun. And we're like these tiny little dust motes going around the sun. And the further you are away from the sun, the slower you move around in terms of degrees per second. So like the orbit of Mars, which is further away from the sun, is about 2 years, and Earth's 1 year. Because Mars is about 50% further away from the Earth from the sun than the Earth is. So it's like Mars, Earth is at 1 astronomical unit, Mars is like 1.5-ish astronomical units. So we're about 8 light minutes away from the sun. Mars is about 12. And so when you want to go to Mars, you basically accelerate along the same path of Earth going around the sun, and you time it such that as that your acceleration gives you an elliptical orbit around the sun, where the tip of the ellipse intersects with Mars. So Mars is going around, and you just time it to coincide with the tip of your ellipse being Mars, and that turns out to be about a 6-month journey. Now you can speed that up. I think I could sort of see a way to make it happen in, say, 3 months, where the intersection with Mars would not be at the tip of the ellipse, but on the edge of the ellipse. Now, that would mean the tip of the ellipse is out near Jupiter. So if you miss Mars, you're going to end up at Jupiter, Jupiter's orbit. So
That's not good.
yeah, and you're going to be coming in hot.
Yeah.
So, but I think probably can get down to 3 months. Not that big of a problem. Getting down to a month is hard. And then Earth and Mars are only in the same sort of. There's only about a 6-month period every 2 years when Earth and Mars are aligned such that you can do the transfer. You can certainly imagine that if Mars is on the other side of the sun, you can't get there because you've got to go through the sun. That's not going to work. So you got to time it. This is like about a quarter of every Mars year is when you can do the transfer. So 6 months every 2 years. So if we are able to build, or if humanity is able to build a city on Mars, people will probably remember, which planetary conjunction they came on. Because it's not like you can just go all the time. You can only go every 2 years.
When do you anticipate, like, how much time before there's regular travel back and forth to Mars? Roughly. Like a real civilization on Mars.
Well, I think it's going to take a while to build a real civilization. The threshold that really matters is, if we're getting past the great filter, is do we have enough resources on Mars such that if the spaceships from Earth stop coming,
You could survive.
Yeah. So now you could only be just missing one little thing. You'd be like, you're on a long sea voyage, and the only thing you're missing is vitamin C. Still not good. It's only a matter of time, you know.
Yeah.
And then it's gonna be curtains. So you got to have all the things necessary to sustain civilization on Mars. And the reason that the ships from Earth stopped coming could be World War III, or it could be due to a slow decline of civilization. So civilization here on Earth could end with a bang or a whimper.
Or natural disasters.
Yeah.
Asteroid impact,
Yeah,
super
that'd be
volcano.
up in the bang category.
Yeah.
But it also could be like a whole series of things. Like, so like what killed the dinosaurs? Well,
Right.
it wasn't just one thing, you know.
Right.
There was like a whole bunch of things happened in a row, and you know, while they could have taken any one of those things, they had like 3 things happen, and no dinosaurs.
Which is kind of amazing that crocodiles are still here.
Yeah.
Those fuckers.
Well,
They're resilient.
Crocodiles, they'll live on decayed meat. They love rotten meat, and so in any kind of disastrous situation, there's a lot of dead creatures, and the crocodiles love it. So that's why they're around. Crocodiles and bugs and mushrooms,
And shrews,
shrews. Yeah,
which is why we're here.
yeah, exactly. Our great grandparents were shrews.
What a strange thing
So like, yeah,
to come from. So there's hope. There's hope for all you rodents out there.
yeah,
One day you can go to Mars. Just keep doing your homework.
absolutely.
So there'll be you say the great filter. What did you mean by that?
Well, so there's something called like the Fermi paradox of like, where are the aliens?
Yeah.
So, yeah, where are the aliens?